Hi, my name is Cindy Williams, and today I will be teaching you about trigonometric identities. Trigonometric identities are important because they teach you to develop new trigonometric identities, verify trigonometric identities, develop additional trigonometric identities, and to solve trigonometric equations. So first I'll give a basic example on a type of fundamental trigonometric identity. These are called reciprocal trig identities. So by reciprocal, your reciprocal is like a fraction, like 1/5. The reciprocal of 1/5 is 1/5, or reciprocals, like things like that. It's the same nature. So sine of theta, the reciprocal trig function would be 1/cosecant of theta. Because if you remember from basic trig that you've learned previously, the reciprocal of sine is 1/cosecant, and cosecant is equal to 1/sine. And another example of this would be cotangent of theta, which is equal to 1/tangent of theta, because 1/tangent is equal to cotangent, so therefore 1/tangent would equal cotangent. And also cotangent would equal to cosine of theta over sine of theta. Because if you remember from using a unit circle, to find tangent, it's normally sine of theta over cosine of theta. So the reciprocal would switch, resulting in cosine over sine. So let's talk about Pythagorean identities. Specifically, this one, cosine x squared plus sine squared x plus equals 1, is one of the most important because it derives the other two. But let's show how this is true using a right triangle. So this side of the right triangle represents the x-axis. This represents the y-axis. And let's just label this r for radius because we're talking about a circle. This equation actually derived from the equation of a circle, x squared plus y squared equals 1. Cosine x equals x, sine x is equal to y. So, with that being said, cosine is also equal to adjacent over hypotenuse, or radius in this case. So cosine would be x squared over r squared plus sine, which is opposite over adjacent, or y over radius, which would be y squared over radius squared. Since these are like terms, we can just combine these as one actual expression. And we have x squared plus y squared over r squared. Now, because of the Pythagorean theorem, we know that x squared plus y squared will equal to r squared. So now this will change to r squared over r squared, which is equal to 1, proving this true. You can derive the other two equations by simply dividing sine and cosine. So cosine squared x plus sine squared x equals 1. Divide everything by sine squared x. So cosine squared x over sine squared x is equal to cotangent squared x plus 1 is equal to 1/sine, which is cosecant squared x. And cosine squared x plus sine squared x equal to 1 all over cosine squared x is equal to 1 plus tangent squared x is equal to 1/cosine, which is secant squared x. Now let's talk about cofunctions. So we're going to focus on one pair. A cofunction, an example of one cofunction is sine and cosine. Sine and cosine are cofunctions. So let's use a right triangle to prove how they're cofunctions. So the actual cofunction equation we're going to try to prove is sine pi minus x pi over 2 minus x is equal to cosine. And we're going to prove that using a right triangle. So these sides, BAC, just labeling this like a regular triangle. This side will be x. So say for instance this number is given. How would you find this angle? Simply by subtracting 90 and x, because these are complementary. Another way of writing 90 is pi over 2 minus x. So pi over 2 minus x, x and 90 degrees is what we have for the triangle. So now we would see how we would get the angle measure of this. So as you can see, for the sine of pi over 2 minus x, you will have to do c over a. And if you observe the cosine of x, you will also have to do c over a in order to get the value. Therefore, proving that the sine of pi over 2 minus x is equal to cosine of x. Okay, so here I have two rays, and what I'm essentially trying to do is to show how the even and odd identity cosine of negative theta is equal to cosine of theta, and sine of negative theta is equal to negative sine theta is true. So here we have two rays, so let's focus on the cosine part first. Here you can see that these two rays have the same x value, the negative one as well as the positive one. Therefore, if cosine of negative theta, if you were trying to find the cosine of negative theta, it would just equal cosine of theta, because they're the same thing. As for sine, you can observe that the sine of this function down here, cosine theta, negative sine theta, and cosine theta, sine theta, are the same distance above or below the x-axis, meaning that this distance is the same as this distance, meaning that they will be negatives of each other. So it is safe to assume that the sine of negative theta is equal to negative sine theta. So now let's do a problem in which we verify an identity. So we have 1 plus cosecant theta all over cotangent of theta plus cosecant of theta is equal to secant theta. So first let's convert this into a normal 1 over its reciprocal. So we have 1 plus 1 over sine theta over, and this reciprocal, which would be cosine theta over sine theta plus cosine theta. So what I like to do is break these into two separate equations, two separate fractions. So we have, in order to add these, we have to get a common denominator, which is sine. So we have sine theta over sine theta plus 1 over sine theta would just be sine theta plus 1 all over sine theta. And at the bottom, we have to make these the same denominator, so we have to multiply this by sine. So we have cosine theta plus sine theta times cosine theta all over sine theta. So now we have sine theta plus 1 over sine theta over cosine theta plus sine theta over sine theta. So now let's, in order to get rid of all of these fractions, we have to multiply by this reciprocal, which would be sine theta plus 1 over sine theta times sine theta over cosine theta plus sine theta times cosine theta. These would cancel out, leaving you with sine of theta plus 1 over cosine theta sine plus sine theta times cosine theta. So now what you would do is take out the cosine at the bottom. You factor out the cosine. So if you factor out the cosine, you will have cosine 1, because cosine divided by cosine is 1. And then sine divided by cosine is sine of theta. As you can see, 1 plus sine of theta is on the top and the bottom, so they cancel out, leaving you 1 over cosine, which is equal to secant of theta, which is what we were trying to prove in the beginning. And that is all we have for fundamental trig identity.